Myself, Dr. Sangeeta Sharma, Associate Professor, PG Department of Chemistry, Government Urban College, बीकानेर। आज हम MSc प्रीवियस यूनिट 4 सरफेस केमिस्ट्री में मेजरमेंट ऑफ सरफेस एरिया पढ़ेंगे। द सरफेस एरिया इज द इम्पॉर्टेंट पैरामीटर इन सरफेस केमिस्ट्री। Area of a solid, not merely the geometrical area but the area of capillaries, pores, cracks and cervix present. The specific surface area is defined as the surface area per mass of adsorbent. Specific surface area is equal to surface area by mass of adsorbent is equal to m square upon g. There are some methods to determine the surface area of adsorbent. The first method is Harkin's and Jura method, which gives relationship log P upon P0 is equal to P minus A upon V square. Here A and B is constant, P0 is the liquefaction pressure of the gas and V is the volume of gas. Slope of the plot is equal to A is equal to K S 1 by half, where K is the universal constant. A plot between log P versus 1 upon V square gives surface area K. The value of K can be evaluated by exposing finely divided TiO2 powder to a sufficient water vapor pressure to form several layers and then immersing sample in liquid water. The heat of immersion of this powder was measured and then surface area is calculated. Benton and White method given in 1931, they noted that sharp break in S-shaped isotherm of nitrogen at minus 191.15 degrees centigrade on iron catalyst at 120 millimeter pressure. The product of the number of molecules in monolayer and molecular cross section gives surface area. The idea further developed by Browner, who applied the PET equation. X is equal to 1 minus XV is equal to 1 upon VMC plus C minus 1 X VMC. For monolayer, X is equal to 0.1 when C is equal to 100 and X is equal to 0.5 when C is equal to 1. It is necessary to find the area covered by each adsorbed molecule for total surface area. Emmett and Taylor assume area of molecule A is equal to 4.866 N upon 4 undergood NB 2 by 3. M is molecular weight of gas, B is the density of liquefied or solidified adsorbent. For measurement of surface area, nitrogen is commonly used as the adsorbent, but the area obtained by the use of adsorbent other than nitrogen differ in many cases due to the larger molecules being screened out of some of the pores of the adsorbent or to irregularities in packing of various molecules on the surface. DT method is most widely used method using DT equation where X is equal to P upon P0. Slope plus intercept is equal to C minus 1 upon C Vm plus 1 upon C Vm, which gives 1 by Vm. Vm is equal to 1 upon on slope plus intercept. 22,400 ml of gas of NTP contain n molecules as Vm ml of gas will contain n Vm upon 22,400 molecules. Surface area of solid adsorbent is equal to Vm Na upon 22,400. A is equal to area of cross section of each adsorbed molecule. The monolayer volume is found out by using volumetric adsorption apparatus. The principle is simple. The pressure, volume and temperature of a quantity of adsorbate are measured by manometer M1 and M2, burette E, and thermometer T1 and T2. The amount of gas present is calculated. The gas is brought in contact with the adsorbent as kept in liquid nitrogen bath T. At equilibrium, gas left calculated with which is difference of amount of gas initially and finally depend on dead space or free space surrounding the adsorbent sample. From radioactive gases F. Page 1922. It is important and highly specific procedure. Tracers can be used either from solution or gas phase for measuring the extent of adsorption and hence area. Powdered lead sulfate shaken with a solution of thorium. Lead thorium equilibrium maintained and interchange of lead thorium occurs and at equilibrium ratio of isotope on surface and solution is in equilibrium. The amount of the thorium on surface and solution and lead in solution determine analytically the number of molecules of lead sulfate on surface can be calculated. The fifth method is point B method. P versus P upon P0 is plotted against volume. P is the first inflection point in curve corresponding to condition when a unimolecular layer is formed. Pb is the volume of gas corresponding to P. P0 into Vb is equal to nRT. For standard condition, P0 is equal to 1 atmosphere pressure and T is equal to 273 degree Kelvin. So N is equal to P0 Vb upon RT. Number of molecules adsorbed is equal to N. Capital N is equal to N P0 V0 upon RT. Total surface area can be calculated by the formula A is equal to N P0 Vp upon RT0 M, where N is the mass of adsorbent, A is the cross-section area of adsorbed molecule. Method applied to all type of solid and gas adsorbate. The A for nitrogen is A is equal to M upon N D 2 by 3, where D is the density of nitrogen at 78 degree Kelvin. Surface area is an important parameter in all physical and chemical processes involving powdered or porous solids. Catalysts used in hydrogenation have activity proportional to total surface. Surface area gives information about the composition of surface of catalyst. Efficiency of catalyst is depend on surface area. Sixth method is permeability to fluid. The volume of a fluid passing in unit time dV upon dt through s centimeter square of a porous plug of length L is given by Cauchy-Carbon equation. dV upon dt is equal to P1 minus P2 S0 upon eta L S0 into epsilon cube K 1 minus epsilon square. P1 minus P2 is equal to pressure difference, eta is viscosity, epsilon is the relative volume of void. One can measure area of unit volume of the solid phase is S is equal to rho specific conductance. Rho is the density of solid. Limitation. First, the plug must be left of fibrous, a compacted powder, but should not contain porous or void with one entrance only. A pore is registered only if the fluid enter it from one side and leave it at opposite end. Second, surface roughness generally lowers the value of dV upon dt, and this may cause an erroneous result. Third, equation derives on the assumption that the gas flow was laminar. If pore diameter is small in comparison with the free path of gas molecules, the molecules fly across the pores rather than roughly parallel to their axis. Seventh method is from electrical potential of adsorbed layer. If metal electrode of platinum oblique silver placed in a solution of sulfuric acid non-reactive, a potential developed can be measured by various vacuum tube voltmeter or sensitive galvanometer. If a small amount of current is made to flow through the system, a potential rise and a plot of potential versus time during the interval immediately after the start of current flow was linear and given by this equation minus E is equal to KQ plus constant. Q is the amount of active material on cathode surface. Value of K vary from one system to next in proportional to area, and the ratio of K for two electrodes should give the ratio of specific surface area. Ackermann obtained area close to BT method. Eighth method is from the rate of dissolution. A very thin layer of a liquid is in contact with a soluble solid very soon becomes saturated. That is, acquires the concentration C0 equal to solubility of solid. The rate of dissolution is determined by the rate of diffusion of solute C0 minus C, where C is the concentration from the solid, to the inverse thickness of the diffusion layer to the area of solid liquid interface. Let M dissolve at time t. Rate of dissolution is dm upon dt. A well polished cube of solid sample 1 and powder of same substance sample 2, then dm upon dt 1 is equal to dm upon dt 2 is equal to a1 is equal to a2. Rate of dissolution is equal to ratio of two area. Area of cube is radially obtained A2 geometrical area can be found. The two most doubtful assumptions is first, the thickness of the diffusion layer is identical in the two samples. The second is the surface region of the powder is as perfect as its core. A2 is the area of the boundary between the saturated film and the unsaturated solution, so it ought to be significantly smaller. Ninth method is from heat of wetting. 1 gram of a powder having surface area is A0 is immersed in liquid. Then A0 centimeter square of the gas solid interface disappear and A0 centimeter square of the liquid solid interface forms. The heat of wetting is minus Q A0 U2C minus U1C. U is the surface energy per unit area.